Good morning. Applications and challenges of additive manufacturing process is presented in this video. First application is dental crowns produced by LPBF, that is laser based powder bed fusion process. Second application is joint implants, that is implants for knee or any other organs in our human body is produced by EPBF. EPBF means electron beam based powder bed fusion process. Third application is ribs and sternum produced by EPBF. Ribs and human body, ribs and sternum in our human body can be produced by EPBF. Then aerospace engine parts are produced by additive manufacturing processes, and lightweight single piece additive manufacturing made antenna is used for telecommunication purpose. This is a single piece antenna and weight is less. And hydraulic and oil parts made for oil and gas industries are made by additive manufacturing technologies. And Ford's anti-theft lock made by additive manufacturing technology. And Ford's door handle is made by additive manufacturing technologies. Challenges and opportunities of additive manufacturing. First challenge for additive manufacturing is availability of qualified materials. Even though there are more than thousands of steel available in our market, only 10 steels are preferable for additive manufacturing technologies. That is, number of powders qualified for use with metal AM systems including laser, electron beam and binder based AM techniques is a key difficulty in metals and metal alloys. More than 1000 steel alloys are commercially available, but only a handful have been validated for AM. Similar to this, more than 600 aluminum alloys were present, only 12 alloys are qualified for additive manufacturing. The lack of parts limits the number of companies that can use the technologies. Because of very few qualified metals, the cost is 5 to 10 times more than that of the materials available for casting, machining and other raw materials. Uncompetitive supplies are part of the problem. Most additive manufacturing material sales total cost is less than 4,000 million US dollar per year, which is a very small fraction of whole raw material business. So qualified availability of qualified material is a challenge for additive manufacturing technology. Then speed and productivity. And comparing to other manufacturing technologies, the speed is very low because it is in mass production. Mass production systems are not available. AM procedures are very slow in speed, and mass production speeds are very high. So the volume have to be increased, working volume have to be increased, and post processing is a very difficult challenge for additive manufacturing technology. To boost AM production, surface quality must be improved, modular flexibility should be added, and multiple heat sources are being combined into a large operating envelope, and automation and intelligent software are being developed to improve the subsystem production. The computer modeling of AM process can enhance production through dependable simulation rather than costly experimentation. So this is also a challenge in additive manufacturing process. And the repeatability and quality assurance, reliability, reproducibility remain major additive manufacturing issues, especially for mass manufacturing. And additive manufacturing is sensitive to environmental and process disturbances including shifting temperature, humidity and particle size. So in additive manufacturing, environmental concern is a very big concern. So full control of the process environment is difficult in additive manufacturing. DED is adding closed loop control, and PPF operations is also closed loop control. Then another challenge in additive manufacturing is industry-wide standards. Despite additive manufacturing's recent advances, industry lacks a complete set of technical standards. Lack of standards may hamper industrial AM adaptation. Even though STL and 3M of standards are available, they are not up to the standard. They are not par up to the increase in the level of additive manufacturing technology. Some of the technologies have been proposed for some process, and for other improvement in other process need other technologies. So several key players have identified a challenge and began acting. ASTM, ANSI, ISO, and other organizations are developing AM standard platforms and methods. ASTM's F42 committee is creating standards for metal AM, particularly LPBF. The created standards could assist the industry to analyze AM system performance and part quality. During these efforts, new dependable standards are needed. Concrete standards should be published rather than partially created ones with shortcomings. If standards are repeatedly retracted and amended owing to weaknesses, the industry will suffer. Then, next challenge to additive manufacturing is end-to-end workflow integration and automation. In other manufacturing technologies, that integration and automation have become incorporated, but in additive manufacturing, there will be no integration and automation. For example, the post processing work such as removal of support structures and the super finishing of surfaces is still a manual working process. So it has to be automated in additive manufacturing technologies. Any integration automation must consider AM's limitations and features. Okay. Then software limitations. So in many cases, 3D model ideas are difficult to print due to unaccounted for process restrictions. And the quality of information and transmission mechanisms affects inter and intra communication and collaboration. So software is a challenge in the additive manufacturing technology. Initial financial investment is very high in additive manufacturing technology, which is also a challenge for industries, those who are willing to adopt additive manufacturing technologies. Then security. So because distributed manufacturing AM systems are distributed manufacturing systems, others can enter into the database of additive manufacturing technologies and can cause damage to the systems. Hence, firewalls should be established in the supply chains to avoid such damages. Then the skill sets gap, and the experienced operators are not available. Experienced technicians and engineers are not available for additive manufacturing technologies, which is also a major drawback, or which is also a major challenge for additive manufacturing industries. Thank you.